Okay, here I'm checking the accuracy of the Yaesu DXA rotor controller. Now this has got the Molex connector on the back of it. So you can see my little tool here. It's roughly got markings on it. And as you turn the potentiometer, you see the needle move. Now my markings might not be exactly accurate as far as what the positions ought to be, but it is at least telling me that as I barely move my tester, the needle moves. And it'll go all the way around until it bottoms out on the south, because I pointed it south over there. And they'll get pretty close to it. Like I say, this is just a rough way to test it. And that's actually as far as the needle will go. And it'll go back the other way. So I'm going to pause it and I'm going to hook it up to another box that takes the 6-pin Molex. And I've got that box right there. And I'll show you what that does. So I'm going to pause and restart it. Okay, now this is the SDX controller that takes the Molex, or the Cinch Jones connector. As you can see, I've just made it so that I can bullet connect whichever connector I want. Here's the one for the Molex. Pretty easy, just swap out connectors. And by the way, introducing the ham supply rotor card for Yaesu that's installed. And here's the cable, just like the rotor easies I do, except this one's made for Yaesu. Okay, this thing has finally figured out where it wants to stop at. And we'll get the little box up here. Now watch as I turn my rheostat. Nothing is happening. Now it's going to go wherever it wants to. And by the way, I did have a G800S box that takes this same connector, and I checked it with it, and it does work perfect. So as you can see, it just wants to go wherever. And you notice it was nothing like the other one, where I just barely turned it and the needle moved with the potentiometer. Okay, now I'll move it back a little bit. As you can see, I am moving the potentiometer. How about that? It did move. But now it's going to move a lot further than what it really should. So this control box has definitely got some problems. I first thought that maybe the belt was bad, but it is turning. And the rotor that came with this control box, I'd put it together and I could not get it to calibrate. So I took the rotor all apart, rechecked everything, put it back together, and that's when I decided that there's something foobar in this controller, because I could get it to calibrate and work perfect with the other one. Now you can see where my potentiometer is. See, it should move. It should move back and forth as I'm moving this potentiometer. No, it did a little bit there. See, now it's just going to go hog wild again. So we definitely got some problems with this one. Anyway, I wanted to illustrate an easy way to test these, so you don't think that you got your rotor built wrong and you got your potentiometer inside the rotor messed up, out of whack. This is the same basic potentiometer that's in the rotor. It's a 0 to 500 ohm potentiometer, and it just happens to be the one that was in the rotor I purchased. That was the wrong one, didn't have a long enough shank, so it wasn't turning the gear, but it is 0 to 500 ohm. Anyway, you can see there that this has definitely got some problems. Maybe one of these days I'll figure it out, or maybe it'll just become a parts controller if I get one with a broken glass or knobs missing or whatever. Anyway, another informative video from Rotors by Scott. Check, check.